Alright, this is theorem 4. Here we're having theorem 4. So what is it that we're told about theorem 4? We need to look at our arc. We've got arc AB here. This arc AB, or we can also say we've got what? A chord AB. Then I put a broken line here so that I may remind myself where the chord is. Now, what am I going to do? I'm going to now follow where this line from point A is going. So observe, as I go up, it meets point D. I go to where point B starts and follow where it is going, it meets point D. So meaning to say that this chord AB, it created this angle D here. Alright, but that's not the only angle that has been created by this chord AB. What else has been created? There is also this angle C here. Let's see. From point B and we go up, and from point A we go up. This angle C is the second angle that has been created by chord AB. Now, what happens? Both of these angles are found on the circumference, right? So, this chord AB, it created angle D and angle C, and angle C and angle D, they are equal. So I come here and I write that angle C is equal to angle D. Now, I want to remind you of something that I once spoke about when I was speaking about what the properties of a circle. I showed you that if I'm to draw a rough sketch here of a circle, and if here I've got a chord, this bottom part is smaller than the upper part, and I said that this bottom part, we call it the minor segment, and obviously the bigger part, we call it the major segment. Major segment. What is the relevance? Observe where angle D and angle C are. They are above chord AB. They are in the major segment. So when they are asking for a reason as to why am I saying angles D and angle C are equal, then my reason becomes angles in the same segment. In the same segment. That's my reason for stating that angle D and angle C are equal. Is that all on theorem 4? No, that's not all. What am I going to do? I'm going to rotate my board so that I can show you the other side. Right? Observe. Here, I've got what? Point D and point C. And if I'm to follow where point C is going, it leads to angle B. Now, if I follow D, it also leads to angle B, which is found on the circumference. So in other words, this angle B, it was created by what? It was created by this chord CD or DC. But this is not the only angle that has been created by chord DC. Let's follow the other line. If I follow this line C, it leads me to point A. If I follow this D, it leads me to point A. So both of these angles they've got a common parent, which is line DC, right? And they are in the major segment, which is this segment here. So which means that angle A is equals to angle B, and the reason will be angles in the same segment. So I'm going to rotate my board and come here and write that angle A is equal to angle B, and my reason will be angles in the same segment. And when I've done that, I'm done. That's what theorem 4 is all about, right? This is what theorem 4 is all about. Now, let me just give you a friendly reminder. Just because we're talking about theorem 4, it doesn't mean to say that when in your examination they separate these theorems. In the examination, they can mix up all these theorems. So now, let's say that here, it was the center of the circle, right? And what am I going to do? Now I'm going to join, I'm going to name it point O here, the center of the circle. And now I tell the examiner that I'm going to join point O and point with point A, and I'm going to join point O with point B. Without doing that, I don't get marks. So it's very important that I write that join OA and OB. Then I join here. Okay. And then I join there. Now that I've joined them, I'm moving from the center to the circumference, from the center to the circumference. And the line which moves from the center to the circumference is what we call radius. Meaning to say that line OA and line OB is what? Radii, the plural of radius. So these two sides are equal. So I say OA is equals to OB. Now, observe. This, I now have got triangle ABO, meaning to say that this O here, this angle here, this O which is at the center, it was subtended or created by line AB. Subtend, to subtend means to create. So this angle was created by chord AB. And observe, or it's just a reminder, angle D and angle C which are found on the circumference, they were also created by chord AB. Now, remember under theorem 2, we said that the angle at the center is twice the angle at the circumference. So in other words, I'm now telling you that this angle O is 2 times bigger angle D. So I write 2D here. The 2 means 2 multiplied by D. I have to multiply D twice in order for it to be equal to angle O. Or I can say D is equals to, I have to halve angle O in order for angle O to be equal to angle D. Also, angle O is 2 times bigger than angle C, which is here. It's also on the circumference. Or vice versa. I can say angle C is equal to half angle O. That's what's happening here. Right. Now, not only do we have that, what do we have? We have got a converse. What is the converse? Let me do this. You see here where there is a chord AB. Now, we found that angle A here was equal to angle B there. And we found that angle D here, it is equal to angle C. And all of these 4 angles that we found that they are equal to each other, what happens? They are in the major segment. So we've got a converse which says that if you are having 4 of these angles in the same segment, it means that you've got a concyclic. So if the theorem looks like this, the converse theorem, it looks like this. Now we're saying that here, this is where the chord is. This angle here is equal to that angle, and this angle here is equal to that angle, and all of them, all of these 4 angles, they are found on top of this chord A, B. So if you have proven that, okay, they are above or they are in the major segment, then it means you've got a concyclic quadrilateral, quad. We already know that quad means 4. Now, concyclic, what does it mean? When you have got a cyclic quadrilateral, it means that these 4 points, we named it point D and point C, A, B, C, D. It means that these 4 points are found on the circumference of a circle. Now it's time to introduce the fact that when we've got what? When we've got a shape or a quadrilateral which has got 4 points on the circumference, we call it a cyclic quadrilateral. And from theorem 4 to theorem 6, we are dealing with cyclic quadrilaterals. So if they ask you to prove, this is one of the reasons, theorem 4 is one of the reasons that you can use to prove that you've got a cyclic quad. Okay, let's meet on the next video where I explain the corollaries. We've got 3 corollaries for theorem 4. This corollary, that corollary, and the last one. Thank you.